Today we're going to continue our discussion of sequences, but we're going to be focusing on arithmetic and geometric types. Last time we were looking at explicit and recursive. Today's topics deal with adding pattern sequences and multiplying pattern sequences. So beginning with the adding pattern sequences, they may or may not give you the formula for this. A lot of times you're just going to have to figure out what the first term in the pattern is. They may also say something about finding the 20th term. So then if you're talking about the 20th term in the pattern, then n is 20. It's which number in the sequence you're discussing at a given time. D is the difference, so that's what number are they adding. It does have to be in terms of what they're adding. So if the pattern is subtracting a number over and over and over again, then your D value is a negative number. So make sure to keep that in mind when it's going up. If it's increasing, it's a positive number. When it's decreasing, it's a negative number. But D is always expressed in terms of what you are adding. And then A sub n is whatever the 20th term is. So I said n is 20 earlier to talk about the 20th number in the pattern. Then if that 20th number is a 37, then A sub 20 is 37, while n is 20 to indicate that it's the 20th number in the pattern. So arithmetic sequences are the ones where we're adding the same number over and over and over again. It has to be the same number. If the number appears to be changing, sometimes it adds 2, sometimes it adds 5, then it is not an arithmetic sequence. There are just generic sequences that follow their own kinds of patterns, but these are specifically ones where you add the same number over and over again. So the formula that we have here states that, say you're interested in the 20th number, then n would be 20. This would be finding what A sub 20 equals, and it would be based on the first term in the pattern, the fact that we're looking for the 20th number, so 20 minus 1, and then you'd be figuring out what number they are adding over and over and over again. So you would plug in the information that you have and solve for whichever piece you're missing. It's not always going to be the A sub n term you're missing. Sometimes you might be solving for which number in the pattern it is. So here's the first example. They've given us a sequence, and I can see from looking at this, it goes from -7 to -4, so it appears to have added 3, and then it appears to have added 3 more, and then it appears to have added 3 more. So right off the bat, I can confirm that this is in fact an arithmetic sequence because it's adding the same number over and over and over again. The number that it's adding is a positive 3. So that's D. Next, we're going to find the 10th term. So looking back at our formula, to find the 10th number in the pattern, that means n is going to be a 10. We can figure out what A sub 1 is by looking at the sequence they gave us. It's just the first number in the pattern. And we just found that D is equal to 3. So we're going to plug in those 3 values into this equation, and then that will tell us what the 10th number in the pattern actually is. So I'm going to write A sub 10 equals A sub 1 plus n minus 1, which is 9. I'm just going to go ahead and evaluate that 10 minus 1 is 9, times the difference of 3. So 9 times 3 is equal to 27. When you subtract 7 from that, you find that the number is 20. And so that's faster than sitting there and saying, okay, add 3 to this, that would be 5, add 3 more, that would be 8, add 3 more, that would be 11, and then keep going 14, 17, 20. So you could do that. You could just sit there and keep adding the number, and that's fine if you're looking for like the 5th or the 10th term. But when you get to questions where they ask you to find the 80th term, it's going to be much more efficient for you to use this formula and plug in the first number, which number in the pattern you're interested in, and what the common difference is. So now we're going to write the recursive rule. The recursive rule is the one that tells you, based on the numbers you know, what will the next number in the pattern be. So to write this, it's A sub n, which means to find the given term you're interested in. It could be A sub 10, it could be A sub 50, whichever number you're interested in. That's going to equal A sub n minus 1, which means the previous term in the sequence, plus D. Because basically, if I'm trying to find the second number in the pattern, I'm going to use the previous number, the first number, and I'm going to add D to it, which in this case would be 3. If I want to find the third number in the pattern, if I'm doing A sub 3, the third number in the pattern is going to be equal to A sub 3 minus 1, which is A sub 2, plus D. So I'm adding that difference value over and over and over again. That's what this is specifying. Now, the other thing you have to state for these is that the first term in the pattern, in this case, was equal to -7, because I need to have some kind of a starting point for me to be able to plug something in for A sub n minus 1. Now I can plug in A sub 1, which is -7, plus d will give me a sub 2. And then I could plug in a sub 2, add d to find a sub 3. Then I could plug in a sub 3, add d to find a sub 4, etc. The explicit rule, that's the formula that we have here, but we are not going to plug anything in for the n or the a sub n values. We're just going to plug in what we know for the first term, because that will never change, and the difference, because that will never change. But the idea of the explicit formula is that we can plug in n is 50 to find the 50th number. So we don't want to plug anything in for n in those cases. So for the explicit rule, I'm going to write a sub n equals a sub 1 plus n minus 1 times the difference. Now, sometimes books will actually have you simplify this a little bit, because you could distribute the 3 times n and the 3 times negative 1, in which case you would have negative 7 plus 3n minus 3. And then you probably see that there are a couple like terms you could combine there, in which case you have 3n minus 10. So that makes it a little bit it makes it a little bit easier to work with, because now I can plug in that if I want to know the 10th term, that's what we did earlier. If I plug in n as 10, 3 times 10 is 30, minus 10 is 20. So it makes it even easier to compute those values, the a sub n's, when you're looking for a specific answer. Now we're going to look at the geometric sequences. So this is the same idea, but instead of it being an adding pattern, now it's going to be a multiplying pattern. So the idea is it has to be multiplying by the number 2 over and over and over and over again. So the important pieces of this equation, there's the first term in the sequence. That's what a sub 1 represents. R is going to be the number that you're multiplying by. It's referred to as the common ratio. That's why they use R to represent it, for ratio. And if you are doubling, then you're putting a 2 in there. If you are cutting things in half, then your R value is 1/2, because this has to be in terms of what you multiply by. N is the term number, just like before. So if we're talking about finding the 20th number, then n is 20. And a sub n would be what is that actual 20th number in the pattern for that example. So this is our explicit rule, which we'll use again in a little bit for the example. So here's our geometric sequence. The first term is 5. So now I know that a sub 1 is equal to 5. It's a good habit to just start off by listing the information we know. So a sub 1 equals 5. The nicest way to find r, this is a pretty easy one to just look at. You can probably tell that they're doubling. But if you're ever having trouble figuring it out, then just pick one of the numbers in the pattern and divide by the one in front of it. It doesn't matter which one you pick. 10 divided by 5 is 2. If I had picked 20 and divided by the one in front, 20 divided by 10, still 2. If I had picked 40 divided by the one in front, it would still be 2. So the best way to find r is to pick a number and divide by the one in front. That'll help you figure out what you're multiplying by to go from term to term to term. So now I know that r equals 2 in this case. So that actually was the first question. They said find the common ratio. Well, we just said they're multiplying by 2. Now they want us to find the 8th term. Yes, you could find that answer in this case by doubling, 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 and then continuing to do that. So the next number would be 80, and then 160, 320, and 640. It's honestly not a big deal on this example since they're only asking you for the 8th term, but I am trying to caution you that sometimes they're going to ask you for the 50th number, and you don't have to sit there and write out 50 multiplications. It's very easy to make a mistake somewhere along the way. So I know the answer is 640, but let's still show you how to do this using our formulas. So going back to the formula, we know a sub 1, and we know r, and then they're asking us to find the 8th number, so that means n is 8. So I'm going to find a sub 8 by plugging in n is 8. So a sub 8 equals a sub 1 times r to the n minus 1. Now in this case n is 8. I'm just going to go ahead and say 8 minus 1 is 7. So now we just need to evaluate what we have here. 2 to the 7th power should be 128, and then we're multiplying 128 times 5, which is where the 640 comes from. Okay, so the formula becomes more and more useful the farther into the sequence you're looking. Now we're going to write the recursive rule. So again, the recursive rule is the rule that tells you how do you find the next number based on the one you currently know. So we want to start off by using our a sub 1, which in this case is 5, but the actual recursive rule is that finding a given term a sub n is going to be equal to the previous term in the sequence, which we call a sub n minus 1, multiplied by r. So if I know the first number, for example, I'm going to take that 5 value, plug it in, and multiply by r, which is 2, and that will give me the next number in the pattern. So 5 times 2 equals 10. And then I can plug in 10, multiply by r, to get the next number. And you can just keep repeating that process. Lastly, we have the explicit rule for the nth term. So that's the formula that you're actually given here. This is the explicit rule. This is the one we generally prefer to use because you don't have to fill in all the numbers in between. It's more useful for jumping around. So a sub n is going to equal a sub 1 is a set value. That's never going to change. The first number in this pattern is always 5. My r value is never going to change. That is always going to be a 2. But the n, that we want to leave as is. Don't plug anything in for n. Because the idea is now I can use this formula to say I want to find the 20th term, so I'm going to plug in 20 raised 2 to the 19th power and multiply by 5. So this formula lets us quickly evaluate any term in the sequence. So that will be all for the notes today. Thank you for your time.